Bonjour, my name is Xavier Plot. I'm a software development manager of the AWS Blu Age qualification and expertise team. This session will be articulated in 3 different phases. So I'm going to be co-presenter with Srini from Transamerica. I will start with first phase where we are going to position Blu Age and make an overview of the end-to-end process. Then Srini is going to give you feedback of the Blu Age project that is gone live. And I will conclude with some demonstration of the Gen AI feature that we embed into our process. So let's get started. If you're there, it's certainly because you are wondering what to do with your mainframe application. So of course, you can always decide to do nothing. So you will keep your cost and third-party license dependency. But if you go with an assessment of your application portfolio, you will certainly discover that some of your application could be eligible to retirement. Some other could be moved to another infrastructure. Some other, again, could be replaced by a product from the market. And for the remaining ones, the business-critical application that you keep maintaining and evolving for business reasons, certainly deserve to be implemented in a more modern technology. For that purpose, you have different options. You can go for a manual rewrite that is going to have a prerequisite of a respecification phase, or you could go for an automated refactoring using Blu Age. Blu Age is not a tool. It's an end-to-end comprehensive process. So we are not going to focus in this presentation too much on the code transformation, but on the process itself and where Gen AI enhanced this process in order to make the project having less cost and a shorter duration. The KPI to measure the efficiency of a transformation process usually are automation and accuracy. The automation is the number of manual post-processing steps you need to get in order to get an application ready to test. With Blu Age, the automation is 100% at the end of the calibration phase. I'm going to explain what it is exactly in a few minutes. Then the accuracy is the quality of that result. So it's the number of defects on the number of line source code, so basically the size of the application that we measure. How many defects did we inject with the automation? So we are going to explore how Gen AI can improve the efficiency of the accuracy and the end-to-end transformation process. The process, the way we see we look at it, is being a set of factories. Of course, there is the bottom left one that is obvious, containing all the tools that take care about the source code transformation and data modernization. But also, you have to validate the result before you go live. So the other factory that is important in this process is the testing factory. It's a huge cost in the project. It's also the longest part, the critical path of the project. It can be very fast to get source code to be tested, and it can be very long to get the quality, the source code being tested to go live. And the third factory, the governance factory, to take care about this project. Your application is live, so it keeps being maintaining and evolving, so the resynchronization of the source code needs to be managed and governed in an automated manner. The delivery and the progress monitoring of the project need to be also something that you take care of and in an easy way, so no manual step to do it. So the Gen AI is a set of API that are at disposal in order to enhance this process. We get a working process with good KPI, and we want to get a better experience for the people playing that process and getting the result that they will go to production. So the automated refactor from Blu Age plus the Gen AI APIs injected into the process are going to give you a result which is going to be something that makes your project shorter and less costly. Looking at the Blu Age delivery model, we are going to read this slide clockwise. It means that we always start with looking at what we will have to do, the code-based analysis. So this code-based analysis is going to give us an ability to give a ROM estimate for the cost and the duration of the project, but also to estimate the effort to be done in the next phase, which is the calibration, in order to reach the 100% of automation I was talking about. So the calibration phase is like a solutioning phase on a portion, a subscope of the application, where we are going to implement the complementary rule set to make that automation done. Then we go to the generalization of that solution in the mass modernization phase to produce the Java application that is going to be verified to check if there is any side effect of the generalization, so defect that need to be solved. And then the validation, so the space in which we demonstrate that there is no more issue and we can go live. If we zoom on the code-based assessment, we get a set of features at our disposal in order to calculate the dependency analysis between the artifacts that compose and implement that application. From this dependency analysis, we are going to identify the missing artifact. We're also going to compare that code base with the functional definition of the scope of the project in order to get rid of the unnecessary pieces to prune the code base. There is no way that we are going to modernize something that will not be testable because it's a decommissioned feature. Then we also have the decomposition, the automated decomposition of the application into application features made of an entry point into the graph, so a way to trigger the function, plus the dependency of artifact implementing that functions, and all grouped together into a work package, and those work package will be grouped again together per functional or technical affinity in order to build the test strategy and put into a timeline that is going to be monitored in terms of progress with automated dashboard, predefined dashboard. That is the way you report the progress of the project. The catch-up phase is when you get some change in the input of your legacy application that need to be periodically and frequently resynchronized with the project going on. The transformation center is made of 3 steps. The first step is the re-engineer of the current implementation of the application into a model that is going to be automatically transformed into another model being object-oriented, from which the third step is going to generate the source code, the target Java source code. And in between, we get a phase where we can inject complementary rules to do the transformation. That's where we can reach the 100% of automation, because we are going to cover the specificity, the specific patterns of your application by injecting specific rules. Then, if we go to the testing factory, as test is representing more than 68% of the cost of a project, this is where we would like to make some savings. Savings in time, savings in cost. And one way of doing it is to look at the cost of a single test case and reduce it with some automation and tools. Another way to look at it is to keep unchanged the quality result or the quality of the result by getting less tests to reach it. So we get a feature to automatically calculate a subscope of the application, like a list of features that is going to be eligible for testing and to de-risk the project. As we do a pattern-to-pattern transformation, we know where we inject risk into the transformation equation. So we know that by calculating some metrics based on those patterns, we can give a ponderation to each artifact, and then we roll it up to the work package and to the features, and we can determine what is the minimum list of features that need to be tested to get a 100% of the pattern covered. So we reduce dramatically the number of test cases doing this by calculating automatically a subscope, which is going to make the test happening faster and the fails discovered quicker. So this way we accelerate the project and we move to the validation final phase before we can go live. Again, the testing factory needs to be seen as something on which you are going to capitalize for future maintenance of this application. So it's a set of tools that will equip a continuous integration pipeline. And this set of tools is made of ways to record some test case scenario, ways to automate the comparison of the result between the legacy and the modernized application, ways to migrate the data set for the test case, and also a standardization of the deployment environment that make no manual things to happen in order to get that application deployed and ready to be tested. So, now that I've presented this process to you, I'm going to hand over to Srini in order he can give you a return of experience on it, and then I will be back for presenting you some, demonstrating some GenAI features.
Hey, thanks, Xavier. Can I take it?
Yeah.
Can you guys hear me? All right, so again, nice presentation. So I'm Srinivas Upadhyaya. I head the technology architecture, engineering, and AI services, and also cloud migrations for Transamerica. So again, excited to be here. I'm happy to share our experiences using AWS Blu Age, how we leverage it to modernize our mainframe applications, right? So quick overview on Transamerica. What do we do? What products we sell? How do we make money, right? So we are an insurance, investments, and retirement solutions company. We have a broad range of products, life insurance, annuities, investment products, and also retirement plans, both individual and in a group. We have about close to 10.7 million customers, all within the US, and we are a 100-year-old institution. So if you're a Transamerica customer, thank you. So, and I think I talked about what the retirement solutions products are. So these are your 401k, 403b, IRA solutions. So most of you at least should have a 401k, right? So as part of your retirement, strategy. So when you think about this retirement, ecosystem, right? The products, you'll be surprised. There's a large set of applications that fuel all these products. I'll go through the numbers shortly, but so it's a combination of distributed applications and mainframe. So we leverage Blu Age in order to modernize all of our mainframe applications. So that's the story. So, but again, let's make it a little bit fun, right? So how many of you guys are using mainframe today, to run your business, right? Critical functions. So I know there are a lot of folks, watching this also virtually, but see a few hands. How many of you think, it's really risky and complex to, do this mainframe modernizations? Raise your hands if you can. So now let's ask Xavier. Xavier, what do you think? You think it's?
Well, in Spanish we say bueno, bonito, barato.
What does that mean?
That means it's going to be quick and cheap.
Okay. So I think I would say, jokes aside, I'll say, the whole Blu Age managed service, the framework, I think it's an amazing product. There's no way we would have pulled off this mainframe migration if not for Blu Age, right? So, so this is again, our Transamerica cloud journey, right? We've been on this journey starting, I would say, 2018, that's initial phases of our cloud migration journey. And on the left side, you see different workloads. On the right side, you see different our strategies that we have used in order to migrate either to cloud or modernize, right? So just think about it, to start with the first, again, new digital applications. So think about it. 2018, 2019, if somebody says that architecture, everybody's hey, cloud first architecture, right? That was the coolest thing. So we did the same, and all of the new capabilities and I would say especially the digital properties, we use modern tech stack. we deployed, developed, deployed, and put it in cloud, right? Again, a lot of cloud native use, services that we've used. The retirement solutions, those three, products that I talked about, and then there's other things like stable value solutions and all that stuff. You'll be surprised, we have an ecosystem of about close to 450 applications and business services, right, serving it. Then, about 4,000 batch workloads, out of which 900 are mainframe batch. And then you have your, the monolithic DB2 on ZOS. I know, Steve, you're here, from IBM, but, and then, your kick screens, you have your satellite databases. We have about 1,200 Informatica workflows, kind of ETL pumping data back and forth. So that was the footprint that we had to deal with. And we, by the way, as of June 9th, all of those workloads, we basically migrated to cloud. How did we do it? So we took those workloads, we divided it into two blocks, right? It was a two-pronged approach. The first is anything that is distributed, we actually went with a replatform route, right? What do we mean by replatform? So that means these applications are already written in Java, C++, older versions. Operating systems are older. So we went through this exercise of upgrade the OSs, upgrade the Java .NET versions, and invest in deployment pipelines, modernize it, enhance monitoring and all of the stuff. So that was the name of the game for that. And then we had all this mainframe applications, so 200 Kix applications like green screen. Then you have your DB2 on ZOS. Then we have about close to 900 batch jobs, right? These are nightly batch that are serving critical functions, your accounting, your kind of trading, right? So every night, like it or not, you have to make all of this batch jobs run, and there's no room for error there, right? So that was the landscape, you kind of had to deal with. So anything distributed, replatform, that means we upgraded the operating systems, et cetera. That was the thing. Anything to do with mainframe, we actually leveraged Blu Age. We went through a refactor rewrite and modernized, again, I'll talk more into that. Then we also have COTS admin systems, right? So we are in the life and annuities business. So if anybody is in the insurance space, right, you buy all this COTS admin systems and you customize and kind of roll out your products, right? So those were deployed on-prem. We're going more and more SaaS route. So that's our strategy when it comes to cloud. The last is, again, data, very critical. I know Paul, he's our CDO, he's here. So we got a great data strategy. So what we are doing is we are approaching this through a data lakehouse architecture, multiple data lakes, and then there's a data mesh overlay. But most important, all these data platforms, we are enabling through data APIs, and we're building data products on top of it. Again, portals are also interfacing. That's the name of the game for that. Let's go to the next slide. So motivation, right? Due to the initial phases, ever try to sell a cloud business case to your board, Tom? How many times did we have to go sell this? About 50 times, probably. Your CFO wants to hear his story. Your CEO wants to hear his story. Business says why, right? All of that, right? So I think the way, at least we were able to pull this off is just from a motivation as well as what are the key strategic priorities, right? The first one was business agility. So the way I want to explain this is you have about 2.5 million lines of COBOL code, right? All your business logic is trapped in it. So anytime business comes to you and says that, hey, new features, we want to launch new products, or there's regulatory mandatory requirements and all of the stuff, say they come to us, we will give our kind of estimates and all of the stuff. Again, the testing and the development cycles, like laborious, like, time consuming, and they did not like it, right? They were like, hey, every time, even some small changes, or even sometimes it's like mandatory, kind of regulatory requirements. So they were like, hey, you need to be faster, right? Like, so what is this alternate solution so that we can, get out of this rut, right? Like, so that was the main ask. Then the second is basically operational efficiency, right? What I mean by operational efficiency is it was more a Transamerica exec, like, CIOs, like our presidents, like, mandate saying, you got to, like, reduce mainframe complexity. Eliminate, even better, but reduce the mainframe complexity, right? That was like a more a TA mandate, TA Transamerica. So then scalability. Business has some aggressive, like, growth goals, right? And they wanted us to, like, say that, can systems scale? Can your portals work faster? And, your nightly batch, right? So we have 900, like, kind of batch jobs. It's like, again, trading, accounting functions. You have to execute on it, and they have to work. And I think our trade deadlines are like 4:30 in the morning, right? So if the business grows and for some reason we are like, past that 4:30 in the morning, like deadline, we have penalties and all of that stuff, right? So you need to like, execute on time and in a meticulous way. And the last is like, risk reduction. So what I mean by risk reduction is whether it's skill set or like, mainframe tech debt. They're like, hey, when are we going to solve for this, right? Like, so don't say that in 10 years you'll do it, then there's no mainframe person left, right? Like, so those were the big priorities. And by the way, there's a lot of like, again, CFO wants, what is the ROI? Why am I spending all this money? Like, so CEO's like, okay, fine, this is going to be great for us to be in the, kind of the insurance map or like, kind of retirement map, fully modernized. So, those were some of the, I would say, key strategic priorities, right? So then, this is interesting. So when we started this journey, you'll be surprised, right? We did not choose Blu Age, So we were thinking, hey, we'll just do a manual rewrite, right? So we took 10% of our workloads. Like, this is, again, some kick screens, batch jobs, like, I think about 30 or 40 data sets. And it was a very isolated function. It was the pension annuities, like, kind of a payment system. So we could do that. And we started the journey, right? Like, so we went through an extensive reverse engineering process. We worked with our business to, like, validate the requirements. Again, time consuming, like, development and testing. And then this constant, like, like a cyclic loop. Hey, go to business and say that, like, hey, can you guys help validate if the outcomes are right and all the stuff. So something that we thought we could do it in like maybe 3 months, guess what, how much time it took? 8 months, right? And in the process, like, imagine the frustration, like, business went through, right? They're like, what, oh my God, it's like, we're like, hey, you need 10% of your time. Instead, like, we're like, sucking up almost good half of their time, right? They should be focused on growing the business, doing the right things. Instead, like, they're like, working with us to, like, make this work. So finally, when we went into production for that 10% of the workload, it was like 8 months. And after that, like a month of like all this bug fix releases and all of this stuff, because your business logic and like, kind of your rules, it's so hard to like, kind of unpeel that from the business side because a lot of the SMEs are gone by then. So we said, hey, this is not going to work. Because if we have to do the rest of the 90%, guess what? It's probably, if lucky, you push people another 5 years, right? That was not acceptable. We had those conversations, with the business. They said, like, hell no. Or how Jamie says, like, heck no, right? So what we did is, like, we looked for alternatives, right? So we built, like, again, some, I would say, like, an analysis, and then we brought in, like, AWS folks, and they said, like, hey, you should take a look at Blu Age, right? So we had all this initial deep dive discussions, and I think what came out is they were like, hey, if not anything, why don't you go through this calibration exercise? And like what Xavier, you kind of talked about it, right? So think of it as a POC, right? They'll look at your mainframe code, put through this calibration exercise, and what the inputs and outputs are. And especially for your code, right, you'll exactly know what you're going to get into. And we were sold because I think there were a few key differentiators that I think I really like was, again, very minimal reverse engineering. They do that behind the scenes, right? But from a customer standpoint, you don't have to deal with it. Then it's a line-by-line code conversion. But don't get me wrong, you can still optimize. Once the code is given to you, you can optimize and do other things. So there was no lapse of your business requirements or your rules. And and then the other best part is when you're going through the testing, functional testing, regression testing, you don't need to involve business. We brought in business only for UAT testing. That was so strategic because in the previous the phase, it was everyday calls with them versus now it's hey, it's ready. Can you guys validate it and help us with the UAT testing, which they loved, right? So we basically again signed the contract. The rest is history. The rest of the 90%, we actually finished the migration in 14 months, right? That was incredible. So then I would say, again, right, we migrated. What is the technology stack that we settled? So this is, again, right, I'm not going to read every line by line, right? But on the left side, you see the technology stack that we used in the mainframe on the on-prem data center. But on the right side, you see the current, again, technology stack in the AWS cloud, modern tech stack that we're using, right? So I would say, again, to kind of go through few, COBOL replaced through Java, right? It's, again, runtime, Amazon Corrado, kick screens, all on the green screen, converted Angular UI, kind of rich. It's a web app. Mainframe batch, we went from mainframe batch to kind of Java batch. But also the good thing is all these batch jobs we actually expose through callable APIs, right? I'll tell you why. Because once we did that, we built an orchestration layer in Python, and our control M was interfacing with the orchestration layer and in turn calling the batch workloads, right? And that actually worked out pretty well. Database, again, we went from DBS, what you call DB2 on ZOS to DB2 on Linux. Right now we're still on EC2s. Hopefully Amazon, the RDS thing, once it's mature, there's an opportunity to flip there. And also from a security rack up to Active Directory, security groups. The two things I was really I would say impressed is through this entire process, we actually basically build fully automated deployment pipelines. Imagine, right, both infra and code completely automated. And the best thing is we built about 7,000 test cases, right? These are your functional, regression, and also performance test cases. So it's like a harness that we have right now. Guess what? I talked about the need for speed, hey, business said do your dev and test faster. Now the test cycles, think about it. You want a new feature, you want a new rollout of a new product. I have a harness, I can run it. And there were times we ran the harness in what, two days, front to back, right? That was amazing. And that gives you so much confidence going into kind of doing these releases, and they're going to be more scalable. And then, so that again, it's basically helping the whole need for speed. Architecture, this is again a very standard 3-tier architecture. Imagine with all the mainframe, legacy technologies. This is something simple. if you recall, probably 10 years back, architecture used to be very similar. 3-tier, you have a UI, you have a backend, you have persistent layer, right? So again, all of the Angular UI, basically, it runs on a Nginx, HTTP server, data access through a data access layer. Our business logic, again, sitting in the business services. The batch jobs, like I said, right, these are all batch Java jobs. And, again, kind of exposed through, RESTful APIs. And the orchestration layer, it was written in Python. And our control M, it actually interfaces with this Python orchestration layer, right? So again, deal with the state management and all of that stuff. And the beauty of this is all of these services, they're running in serverless, ECS containers. So imagine now the skill set that I'm talking about, right? Earlier, mainframe, what you call legacy, kind of skills and all this stuff. This one, I can go to the street, look at the number of people that came to the conference, right? It's like any of, those, again, if you're a smart developer, you can actually do this, right? And we have some serious, really good implementation partners. If I say that, hey, I want this done in 3 months versus 6 months, you can double down the capacity in terms of the number of resources and, get the game up. Let me see what else. This slide is going to flip because I think we have this timer set for this for some reason, in case it flips. Again, outcomes, think about it. The priorities that so see, that's why it's clipped. So I'm still fine. The priorities that I said, or we said, when we started this journey, right? Think about it. Business said, need for speed. So first of all, if the business grows, we can scale, right? And we have demonstrated that in the last 6 months many times. Our nightly batch, believe it or not, it's 30% faster. This is, again, just conservative, right? Usually, basically, it's our deadline is 4:30 a.m. in the morning Eastern, where the trade files have to go out. A lot of times in the mainframe world, it used to be 3:30. It's always a little bit of a nerve-wracking, and somehow you pull it off. Now, a lot of our batch, we're done by midnight. So imagine the cushion we have. So whether it's for mandatory deadlines or most importantly, market demands, right? So with their architecture is simplified. The reason why I say is now it's a distributed architecture. And also the systems and the data, both are in the cloud. So portals are faster, batch is faster, right? So, and also it's integrations with the rest of the ecosystem is easy. I think there are 2 things that we also enhanced security. We implemented network segmentation and also better access management segmentation, both for major products and also across the lifecycle environments. We've done both. And resiliency, again, we have multi-AZ support that we have implemented. DR support we have, again, immutable backers, you name it. And last thing, we went from something that's a fixed cost, from a pricing to variable cost. So if the business volumes grows, of course the costs are going to go up, but you don't have to make it more a capital expenditure game. This one, very important slide. Again, right, when we started the journey, if somebody told me all these things, I think life would have been such easier, right? So a few things I'll call out. Data gravity, it will be a challenge, right? Think about it. When we went through the distributed systems, it was a lesser of a challenge. Mainframe, imagine, close to 900 batch jobs. You have your kick screens. You have all these other applications, tied to, kind of mainframe. That was the June 9th cutover where we had to, flip everything one shot, right? So imagine, when you're going through your application sequencing, pay attention to it. Otherwise, you will end up with performance risk. So it's doable, but pay attention to it. calibration exercise like, Xavier did. They do a great job. Usually it's about 3 to 4 weeks, but you will know exactly, again, your mainframe code, how it works, how the tool can, kind of deliver the results. You see the inputs and outputs, and, think of it as a POC. It's well worth it. Invest in it. Overall testing, like I said, 7,000 test cases, right? That's a byproduct. There are 2 other testing, I would say, tactics that we use. One is called parallel testing. I'll talk about what that is, and then mock runs. I'll say that if not for those 2 things, I would be shit scared, kind of doing this migration. So the parallel testing it's for the nightly batch. We have 900 batch, jobs that run every night. We ran 100 parallel tests, right? And we used 10 data sets. A data set is something like your tax day data, right? Or your monthly, what you call the data set, or your quarterly data set, or your year-end high volume days, right? So we had about 6 or 7 flavors. And we took multiple data sets of those data. And every parallel run is, we would take one of the data sets, we would run it on-prem, run it in cloud, and we would do a data comparison of the output, hundreds of millions of rows, right? We had accelerators to help us do that. But every time you do it, you will have issues. Blu Age, what is the turnaround time for them to kind of do a code fix? Take a guess. It's 24 hours for the most part. We would report an issue. I know for the time difference, by the time we wake up, we used to get a code fix, right? Which was amazing. Imagine if all of our development teams did that. So, but I'll say that that really helped. And by the time we were getting close to 80, 90, 100 parallel test runs, we were super confident. Then the second thing that really, really helped us is something called mock test runs. So this is basically again, we have a parallel prod set up in production in AWS. So we took 3 weekends, one in March of this year, one in, again, April and May. So we used to take the production workloads on-prem. This is the true production. We would put banners so that no external traffic comes in. We would flip it to kind of AWS pre-prod, test it, we'll find issues, and we'll flip back. So very first one that we did in March, we had 60 issues. We went through those analysis, in a prem, and then we fixed those, and we did the second mock in April. The issues came down to 16, right? Fixed those. We did the third mock. I think it was the Memorial Day weekend. It was a 3-day weekend. The issues were 0. So now, on June 9th was the final cutover, right? So it was intense, but we did it. We finished it final cutover. And the most amazing thing is, and again, you guys are familiar with mainframe, right? So you see the number of MIPS and the costs, associated. On June 9th, it was I think the peak is 11,000 MIPS, and we pay 14 or 15 grand. Once the cutover was done, it dropped to 0. Right? That was amazing. Then what else? Upskill your cloud talent. That's a given. Again, internal teams. Hire the right people from outside, and also pick the right implementation partner. Again, in our case, it was Blu Age, and also for the overall cloud migration, we use Infosys. Right? Great partnership. They've been with our journey, all through for about 2.5 years, right? Some solid, I would say, talent there. And rationalized software, right? So this is, there's a guy here, Ted. He's the King Kong of the software rationalization, right? So you give him 100 software items, he will figure out, or at least we were able to figure out which of these are again, can we leverage cloud licensing models? There's opportunities there. If you do that, definitely you can save some money through the process. And then communication, again, extreme communication with our stakeholders like business, operations. And we use some unique, I would say, kind of strategies with our business, right? Like I said, we used to bring them only for UAT because the rest of the testing, we could take care of it in the Blu Age world. And they were super appreciative because think about it, right? Now it's like, the burden on them is less. So we use them for UAT and the mock runs. So those were the two things, we'll double down. And of course, you have to keep your risk, audit, your operation folks, everybody, kind of engaged, trained. So I would say these are the, the takeaways, if I have to, do it. So again, this is, a quick statement testimony from our CI CTO, Tom, is right here. So again, this is him saying, technology saying, but also this is our business saying to kind of technology and Tom, right? So two things. What we have done is phenomenal, right? Again, this is nights and weekends and blood and sweat in order for us to get to here. And also, this is not a pure tech upgrade, right? Think about it. We have modernized our applications. They're more secure, reliable, and available. We laid out the foundation for future, right, from an innovation standpoint. And thing is, the way I would call it is, now that all of the systems and data, they're all in cloud, our path to, any future innovation, right? If you want to put on any new innovation products, and especially I run the AI services as well for Transamerica, so this is going to make it so much easier, right, with the data and systems together. With that, again, this is the last slide. I want to take a minute to do some shout outs, again, great partnership, with the Blu Age team, couldn't have done without them. Infosys, I know some of you guys are here, 2.5 years of journey, again, daily stand-up calls, an hour in the morning, it was just insane, but extremely, really talented, and kind of, they had the grit to pull this off with us. IBM, again, Steve, you and your team, great job. I know you're converting, we are with DB2, so we're going from ZOS to what you call Linux on EC2. Hopefully we can get to the RDS someday. But again, awesome partnership. And then we have also our infrastructure team from Aegon, Atif, you're here. So they run our on-prem data center. So great partnership there because it's but above all, the Transamerica technology and kind of business teams. I wouldn't call them amazing because in TA we don't call people amazing. We call them trans-amazing. So you guys know who you are. Awesome job. And thank you so much. And with that, Xavier, back to you. Go with the demo. Thank you all.
Thank you, Srini. So let's look at the GenAI features we have. So I said the KPI are the automation, we get 100%, and with the accuracy, we are at 99.996 with the ZOS COBOL transformation. So we are good. So where are we going to put the GenAI features? In the factories, everywhere, or in the comprehensive process, where we are going to accelerate the other tasks and the source code transformation. And why not also the source code transformation in some case? So the GenAI feature we get added into the process can be articulated around 3 different positions. The one that will ease and speed up the process in order to do the assessment, so the preparation of the project, where you set up your timeline and you anticipate everything you have to solve in order to get to the 100% automation. Also, when you will have to solve the defect that exists, you will have to make some root cause analysis. And for that purpose, we need to enhance the experience of the developer looking at the root cause of a bug. So again, we get some GenAI feature to help on this. The project management, so the idea is to that the people can concentrate where they have an added value, not to do the reporting or the things with Excel-based and so on. So that's why we get predefined dashboard and so on. But we also get some generic features that are going to facilitate the reporting and the organization of the project. And the transformation itself, because in some case, the Blu Age engine will not cover a given technology. That could be a piece of a given application, but we also have to transform it automatically. So we are going to start with the artifact categorization as a generic feature. So this, out of the box, the engine is going to recognize what type of artifact we are facing by looking at the content of the artifact. But in some case, it's going to fail, or it's not going to be successful because the artifact is not understood by the engine. So for that purpose, GenAI is going to look at it and complement the categorization. And here we get an example with the fixed width text, fixed width data, a file that has been automatically categorized by the GenAI feature. Also, the legacy code summary. So it could be interesting to get a summary of what a program is doing in order to do the root cause analysis of an issue, or to better relearn and understand what a piece of an application is doing. So we can run on all the program, the GenAI feature, in order to get a summary of every single program, what it is doing. And this result is added as a property on the artifact into the tool. And as it is a property, you can easily query that property in order to get some information or locate a given program. So here the query we are typing is to locate programs that take care about account. So it's an account management team application. So this list of screens and programs are taking care about account. And we can complement that query in order to have a look at where some account has been updated or could be updated using the application. And we are down to a single screen with just 2 queries that we have typed among a large code base. Okay, so that's very easy to locate without knowing the naming convention. The Do It For Me feature is for the project manager. So imagine that you go in a weekly meeting and then you take notes. And in those notes, you get some list of things that are different. So some of them are related to a task that you want to assign to someone. Some of them are related to the fact that someone is announcing that he will be off the project for vacation for a given period, for instance. So all of your notes are there, and you have the GenAI features to recognize them. So here we get an empty calendar, and we get the weekly notes that has been taken by the project manager. And GenAI is going to process them and automatically, from the notes, take them one by one and recognize them as a task that need to be inserted into as a card that is automatically assigned to the person who is present in the system for this project. And you can see that they are appearing by the process is going on. Then the vacation of the person who is planning not to be there is also going to be inserted into the calendar of the project. So it means that you can, something which is automatically done again, so you don't need to get any kind of other artifact in order to get a vision of your project. So here we can see that the day off is being captured and AFAF is in vacation for a given period. It's also going to be in the calendar here. But this person being off the project for a few days, when you're back, you could be interested by understanding what's going on and what happened during your absence. So we get project activities summary for that purpose. So it means that instead of going through the breadcrumb or all the events that happened during the project that are logged here in that track mechanism, you get just a couple of summary that give you what happened when you were not there. Command translation. Sometimes you are in a source code, you are making a root cause analysis, but the program you are facing has been written by someone not speaking your language. So you don't understand what are the comments about. So here we get the Japanese source code, for instance, with some Japanese comment, for instance. And obviously, I don't speak Japanese and I don't understand it, so I need to get translation. But instead of taking the comment and copy-pasting it into a translation tool, I can ask the GenAI feature to automatically translate all comments present into the source code in an English that I can understand. This does not alter the original file. So it means that when I close it and reopen it, I'm back to the Japanese, but as that has already been done, I can be back with my English translation in a second. It's also the case for the other example here, where it's a Spanish source code comment that we get and that can be translated. The query in natural language. As you saw, in every single screen of the tool, of the Blu Age tool, the Blu Insight tool, we get a query bar where we can query the data that are in the page. So it could be the dependency tree, it could be the artifact, it could be any kind of data that we have in the page. We are able to query it against the properties as we saw it earlier. So here I'm going to use a GenAI feature in order, because I'm not familiar with the syntax or the grammar of this query language. So I'm going to type in a plain full English readable text to say, okay, I want all programs having more than 100 lines of source code. And then this is automatically transformed into a query of Blu Insight that is applied to the code base, and I get my result. You can do the same with a graph, so you can query the graph without knowing the query language. The legacy source code explanation. So we saw that we can translate the comment, but with GenAI also, we can have very long programs, so a batch of 300,000 lines of source code and so on. So we could have not a real understanding of what's going on a piece of that source code or the full source code itself. So we can select the source code and have the GenAI feature in order to give me an explanation in English of what this source code is doing. The legacy screen preview, it's about, without running the application, understanding what a screen looks like. So it means that with the screen description, it's not easy to get a rendering in my eyes. So I'm going to have the GenAI features to take that and to give me, without running the application, the rendering of that screen. So it's very helpful, so I can better understand what are the options for the end user, what are the actions that can be performed on the screen, and it's going to help me to get more quicker to the root cause. The transformation center, as I said, sometimes you get in an application some artifacts that are implemented in a language that is not familiar to the Blu Age tool. You get the choice, for instance, to manually rewrite them. But we don't want to get there. So we are going to have the GenAI feature. Automatically, the transformation center is going to solicit, when Blu Age does not do it, the GenAI feature to do the transformation. And then here we get, for instance, for EasyTrieve reports, transformation into Java that is going to be displayed side by side, so you can see the report on the right and the Java source code on the left. It also applies to some other language, like the C, but for the low-level routine, sometimes we don't want to get a transformation as a result of a line-by-line transformation or a GenAI transformation. So we just use the result as a baseline, from where we are going to adapt things in a more object-oriented manner to get the final result. So here we are going to see C transformation and how it goes into Java. So everything I'm showing you is to enhance the experience of the developer making the transformation to go faster on all other tasks than just the source code transformation. The purpose of those GenAI features is really to get to a point where everything which is around in terms of managing the project, so in the project factory or into the testing factory, are going to be done quicker and faster. The capture and replay feature is very important. So it's a feature that we have that we can give to a customer in order that their end user can record what they do with the application in order to capture a test scenario. So it's going to record every single typing, every single input, every single pause, every single keystroke, and so on. And from there, we are going to automatically produce a Selenium or a Playwright script in order to reproduce this scenario onto the modernized application. But more than this, sometimes it's painful for a customer to give you a set of test cases that are going to be enough test case to demonstrate that the result of the transformation can go live. So we can ask the GenAI features to look into the screen, get an analysis of it, and determine what are the available options that an end user can do on this screen, and automatically invent on the fly the scenario and complement the initial test case that the customer gave us in order to test the application with additional test cases that are going to be invented by this process. And it's realistic test case because it's based on the screen content and the options that are offered. Then I can download the file as a result of this recording of the test case in order to replay it. So I just edit the playwright file, and then I put the URL of the application and the ID of the entry point where we are going to start the scenario. Once it's done, we can easily replay that scenario on the target application. As a result, we will have the execution of the exact same scenario on the modernized application, and we will be able to compare the result of that execution with the execution of the same scenario on the legacy. And so this way, we are proving that the transformation did not alter the behavior of the application or the end user experience. So here we are tracking everything that happened with the replay, and we get the conclusion. What is important is that by having the capability with GenAI to invent new test cases, at the end, we can get better coverage of the source code. And if you couple this with the dependency analysis that we get on the artifact, it means that we can predict the test case coverage, and that will be verified using Jacoco later on when we will run the scenario. But this way, we can invent, we can get traceability, we can get test coverage, and we can say, okay, we need to get some test case going in this direction of the graph because this other direction is already covered. So all those features that I just showed you as a demonstration are live features. They exist in the tool, so you can have access to them if you get access to the Blu Insight tool, and you can consume them on your daily work. This slide is making a summary of what we just saw. As a complement, you will also have some other reading online that exists, so the documentation that I invite you to go through. And as a wrap-up, so this is the list of other mainframe modernization related sessions. I made a zoom on the one that happened yesterday, but you can have access to the replay using the QR code. This is the session where Fujitsu-san, because it's an organization, talked about their strategy of mainframe modernization, and they were also talking about Blu Age. So we had a partnership signed this year with them in order to expand our transformation process to the GS21 Fujitsu platform. So we are now capable with them to address their own customer on a double byte transformation running on a GS21 Fujitsu platform. Thank you, everyone. I was happy to present to you today.